Welcome back to the deep dive. We are ripping open your source material again today, digging out those key nuggets of knowledge just for you.
And what have we got?
We're looking at a really interesting document about, well, one of the world's most prized spices, saffron.
Saffron. Yes. We're looking at an Indian
Mhm.
standard document, IS 54531, 1996 to be exact. This is the official spec for saffron from the Bureau of Indian Standards.
Right. And our mission today is basically to take this, pretty technical standard and decode it. What does it actually mean for saffron to meet this national quality standard in India?
What are the rules, the definitions, the test?
Exactly. Think of it as the official blueprint for what saffron should be according to this specific standard.
And what's really quite striking right from the start is the context the source itself gives for this standard even being public.
Yeah.
It links it to promoting the right to information in India. Transparency, access to knowledge.
Oh, interesting.
Yeah, the document actually has these quotes in it like, invent a new India using knowledge, step out from the old to the new, and the right to information, the right to live.
Wow. That's quite profound for a technical standard. And there's another one too, isn't there? Something about knowledge being treasure.
Yes, knowledge is such a treasure which cannot be stolen.
Yeah.
It really frames the whole thing differently, doesn't it?
It absolutely does. It turns it from just, a dry set of rules about a spice into something with this bigger societal purpose, making information accessible to everyone, including learners like you. It's not just about saffron quality, it's about open standards.
Exactly. It makes this seemingly niche document sort of a symbol of public access to knowledge. But okay, let's dive into the saffron itself. What does the standard actually specify?
Okay, let's unpack it. So the document is IS 5453, Part 1, 1996, Indian Standard for Saffron, Part 1, Specification. And it's the second revision, adopted by the Bureau of Indian Standards, BIS, back in 96.
Right. And it's the definitive guide for saffron from the flowers of Crocus sativus linnaeus. That's the specific plant.
And it covers the two main forms you usually find it in, right?
Yep. Whole filament and powder form.
The standard even gives a bit of history. Apparently, it was first published way back in 1963,
Wow.
revised in 1980, and then this 96 version was updated to align with an international standard, ISO 3632, and also India's own food laws, the Prevention of Food Adulteration Act from 1954.
So it's got history, but it's kept current with international norms and national regulations. Makes sense.
And what's really key is how it starts by precisely defining all the bits and pieces you might find.
Laying the groundwork, the terminology section.
Exactly. First up, saffron in filament. Describes them as the dried stigmas of the Crocus sativus flower. Got to be dark red, trumpet-shaped,
Yeah.
serrated or indented at the far end, the distal end, and there's a specific length too, between 20 and 40 millimeters. And it notes these red stigmas might still be joined, maybe in twos or threes, to a little bit of the style, which is described as whitely yellow.
Right, and that distinction leads to the next term, saffron in-cut filaments.
Which is.
That's when those styles are completely removed and the stigmas are all separate, just the red bits, basically.
Got it. And saffron in powder is just crushed filament.
Simple enough. But then it gets into what isn't the main product, but it might be present.
The potential contaminants or less valuable parts, like yellow filaments.
Yes, specifically defined as the dried yellow stamens of the flower. So a different part entirely from the red stigmas.
Okay. And then there's floral waste.
Right. The standard is very explicit here. It's yellow filaments that are detached, pollens, stamens, bits of ovaries, other parts of the crocus flower. Basically, anything from the flower that isn't the valuable red stigma or its attached style bit.
So flower debris, essentially. And lastly,
Extraneous matter. This covers leaves, stems, chaffs, other plant bits.
Yeah.
But crucially, it adds including mineral matter, such as sand, earth, and dust.
oof, yeah. You definitely don't want sand in your expensive saffron.
Absolutely not. And these precise definitions are critical because, well, they're the basis for the whole grading system.
Ah, yes, the grading. This is where those definitions really matter, isn't it?
Totally. For saffron filaments, the standard lays out 4 grades. Grade 1, Grade 2, Grade 3, and Grade 4.
And it's graded based on...
Based solely on the amount of that floral waste and extraneous matter we just defined. It's all about purity from those unwanted bits.
Okay, let's see the limits. Table 1, right. Grade 1.
Grade 1 is the top tier. Maximum 0% floral waste, maximum 0% extraneous matter.
0%. So completely pure red stigmas.
According to this standard, yes, if it's grade 1, it should be free of any other flower bits or, dirt.
Wow. Okay, grade 2.
Grade 2 allows a tiny bit, max 0.5% floral waste, and max 0.5% extraneous matter. Still very, very pure.
Right, grade 3.
A little more leeway there. Up to 1.0% floral waste and 1.0% extraneous matter, maximum for each.
And grade 4.
That allows the most, though still relatively small amounts. Max 1.5% floral waste and max 1.5% extraneous matter.
It's interesting how this lines up with traditional names mentioned in the standards forward. It mentions selected quality, or mongraya,
Described as all red, mainly broken stigmas.
which sounds exactly like grade 1 or maybe grade 2, right? Very little waste.
Precisely. And then it mentions unselected quality, or LHEHGA,
Which contains some yellow filaments and floral waste.
fitting perfectly with the description for grade 3 or 4, where those things are allowed in slightly higher amounts.
So the standard gives a scientific measurable basis for these traditional quality terms. That's pretty neat.
Yeah, it connects the traditional assessment with objective criteria. But beyond just the physical stuff, the standard also gets into the intrinsic quality.
Like the flavor and smell.
Exactly. For flavor, it has to be characteristic of saffron, described as slightly bitter and slightly pungent. And, crucially, free from any foreign flavors.
Makes sense. And no bugs or mold, I hope.
Definitely not. The standard says free from living insects and practically free from mold, dead insects, insect bits, and rodent contamination.
Practically free.
Yeah, I guess tiny traces might be unavoidable sometimes,
Yep.
but it should be negligible. They even mention checking visually or with up to 10x magnification.
Okay. What else?
There's an identification test. Basically, a check to ensure there are no added colors or other organic stuff that isn't naturally in saffron. For powder, they specifically mention using a microscope too.
Good check against adulteration. And didn't you mention an amendment?
Ah, yes. Amendment 1 from 2008 added a key safety requirement. Salmonella must be absent in the 25G sample.
Right. Important food safety update. Good to see the standard evolves.
Absolutely. Now, this next part is where it gets really scientific, but the chemical requirements, detailed in Table 2. This is where they put numbers on quality for both filaments and powder.
Okay, the science bit. What are the key things they measure?
Well, you've got standard stuff like moisture and volatile matter. Max limits there, 12% for filaments, 10% for powder. Important for, shelf life and weight.
Uh-huh. And ash content?
Yep, total ash has a max limit of 8%.
Yeah.
But the really telling one is acid-insoluble ash,
Why is that one special?
because its limit varies by grade. Max 1% for the top grades 1 and 2, but it goes up to 1.5% for grades 3 and 4.
And that indicates?
It's a direct pointer to mineral contamination: sand, earth, dust. Remember the extraneous matter definition. Higher acid-insoluble ash probably means more dirt.
I see. So it links back to physical purity but measured chemically.
Exactly. There's also a simple solubility and cold water test. Max 65% limit. Just checks how much dissolves.
But the real heart of the quality metrics, the things that make saffron, must be the compounds for taste, smell, and color, right?
Absolutely. And the standard measures these. First, bitterness. This comes from picrocrocine.
Picrocrocine. Okay.
And they measure it using absorbance at a specific wavelength, 257 nanometers. Think of it like measuring how intense the bitterness compound is.
And how does this relate to grade?
The standard sets minimum requirements, and they increase with the grade. Grade 1 needs a minimum score of 70, grade 2 needs 55, grade 3 needs 40, and grade 4 only needs 30.
So higher grade means guaranteed higher minimum bitterness. Interesting. What about the aroma?
That's mainly safranal.
Yeah.
Measured similarly by absorbance, but at 330 nanometers.
And the grades.
Here it's different. The standard sets a range for safranal. Minimum 20, maximum 50.
Yeah.
And this range applies to all grades and forms.
Oh, okay. So the aroma level is expected to be within a certain band, regardless of grade, unlike bitterness.
Seems so. It suggests that while bitterness and color differentiate grades, the characteristic aroma should be present within this defined range across the board.
Right. And the big one, color.
The coloring strength. This is mainly from crocine, measured by absorbance at 440 nanometers. And like bitterness, the minimum required levels vary hugely by grade.
How huge?
Grade 1 needs a minimum score of 190, grade 2 min 450, grade 3 min 110, and grade 4 only a minimum of 80.
Wow. So grade 1 needs more than double the minimum coloring power of grade 4.
Exactly. This shows coloring strength is a massive factor in how this standard differentiates the grades. It's a key quality marker.
Makes sense that deep red color is so iconic. They also check other things.
Yeah, briefly. Limits for total nitrogen, max 3%, and crude fiber, max 6%. It's a pretty comprehensive chemical profile.
So it really goes beyond just looking at it. They have hard numbers. How do they make sure these numbers are right? Testing.
Yep, the standard covers sampling and analysis too.
How do they get a sample? Just grab some.
Yeah, bit more formal than that. It refers to another Indian standard, ISC 13145, for the method, specifies a minimum lab sample size of 10 grams.
Okay, enough for testing.
Enough for most tests and duplicate, yeah. Though they note you'd need more for nitrogen or fiber tests. And they add a practical note. Do the tests quickly after preparing the sample.
Because saffron's delicate, right?
Exactly. Quality can change.
So once it passes all these tests, how does it get packaged and labeled?
The standard covers that too. Packing needs to be watertight, sound, clean, and made of something that won't affect the saffron's quality. No weird smells leaching in, no moisture.
Standard stuff for food packaging, sounds like.
Yeah.
And marking. Labels.
Quite specific requirements there. Each container has to show processor packer name and address, Saffron is the material name, any brand name, the type, filament or powder, and very importantly, the grade 1, 2, 3, or 4.
Right, the grade is key. What else?
Batch number for traceability, net mass, year of harvest for filaments or the month year of packing for powder, and a best before date.
And legal stuff?
Yep. Any other markings required by Indian law, like weights and measures rules or Food Adulteration Act requirements, it ensures transparency right on the package.
So we've gone through definitions, grading based on physical purity, detailed chemical requirements for bitterness, aroma, color, packing, labeling. Why does knowing all this detail from IS 5453 actually matter to you, the listener?
Well, understanding these specifics, what floral waste is, how grading hinges on it, and especially those minimum chemical levels for picrochrosine, bitterness, the range for safranal aroma, and the big differences in minimum crocine color, it gives you a really powerful lens.
How so?
It provides a solid official framework for what different levels of saffron quality actually mean, scientifically. If you see a product claiming grade 1, you now have a much better idea of the rigorous purity and chemical standards it should meet according to this Indian standard.
So it helps you judge, value, maybe spot if something seems off?
Exactly. It helps understand why grade 1 costs so much more. It's tied to measurable things like much higher coloring strength and near-perfect purity. It moves quality assessment from just subjective feel to something grounded in objective testable criteria defined by a national body.
It demystifies it a bit, takes away some of the guesswork.
Precisely. You get a shortcut to understanding the science and regulation behind this ancient valuable spice.
Okay, so quick recap. We started with your source, this Indian standard for saffron, IS 5453, framed by that neat message about accessible knowledge. We unpacked its core. The definitions, the grading system based on purity, the key chemical benchmarks for bitterness, aroma, and especially color strengths, plus the packing and marking rules.
It really demonstrates the kind of deep understanding you can get from digging into one specific, focused document.
Totally agree. And as we wrap up, here's a thought to mull over, building directly on this standard. Think about how these very precise scientific measurements, absorbance units for crocine, percentage limits for ash, how do they intersect with, or maybe differ from, the traditional ways people have judged saffron for centuries?
You mean just by sight, smell, taste?
Exactly. Looking for that deep red, smelling that unique fragrance, tasting the bitterness. What does the addition of this kind of scientific quantification, as laid out in the standard, actually add to our understanding and appreciation of saffron? Does it enhance it? Does it replace tradition? Or do they complement each other?
That's a great question. Science versus sensory tradition.
Something to think about. What does science truly bring to the table for an ancient spice like this?
Mull on that until our next deep dive.
See you next time.